Welcome to the demo for the AWS Fault Injection Service, AWS Availability Zone Power Interruption Scenario. When we think about real-world applications, like for example pet adoption application, they often have not many logical components. Pet site will have user interface, search capabilities, service to process adoption, as well as database to retain the records. At the same time, architecture for this application may have many components. Pet site user interface built on Amazon EKS with Amazon EC2 compute. Pet site search capabilities on Amazon ECS with Amazon EC2 compute. And payment processor on Amazon ECS with AWS Fargate, Amazon RDS, Amazon API Gateway, AWS Lambda, Amazon DynamoDB, Amazon S3, and so on. AWS FIS Scenario Library make it easy to execute a complex experiment, such as availability zone power impairment, with just few clicks. Let's take a look how you can do that. This demo is based on the Bootstrap Your Chaos Engineering Journey with AWS Fault Injection Service Scenarios Library blog post. Please use the guidance from the blog if you'd like to repeat what you'll see in this demo. In the AWS console, we'll search for the AWS Resilience Hub service and select it. In the Resilience Testing section on the left-hand side, we'll select Scenario Library and choose the Availability Zone Power Interruption Scenario from the available scenarios. Click Create Template with Scenario. In the Specify Template Details dialog, we'll leave description with the default values. We'll need to define the experiment type. This can be both single and multiple AWS accounts. For the purpose of this demo, we will select this AWS account. Then click Next. In Step 2, Specify Actions and Targets, we'll see a list of actions for this experiment and need to configure them. First, we'll edit shared parameters. In the Required Scenario Parameters section, we need to provide two important parameters. Specify the AWS Availability Zone, where we'd like resources to be affected by the experiment by selecting the value from the Affected Availability Zone list. I'll select US East 1A. For the affected roles for insufficient capacity exception field, we will search for the IAM role. As we don't use third-party scaling tools, like Carpenter, this role won't be used in the demo. In the Advanced Parameters, Targeting Tags, we need to specify the AWS tags and their expected values that have been used to identify the AWS resources in scope for this experiment. I have tagged all the AWS components of the pet site application with the tag with the key, AWS impairment power, and value, ready, which I'll use here. In your real environment, you may want to have different key, value combinations for different type of the resource of your application. In the Advanced Parameters, Duration section, I'll update the duration value for the main stages of the experiment. I'll set DNS impact duration to be 2 minutes, outage duration to be 10 minutes, and recovery duration to be 5 minutes. Save shared parameters. I'll leave experiment options as is, and proceed to the next step. Pre-deployed IAM role will be selected for the experiment. Leaving stop conditions, as is, I'll configure the experiment execution report. I'll select the Amazon S3 bucket where experiment report will be stored. I'll include CloudWatch dashboard metrics information in the report. In the list of the CloudWatch dashboards, I'll select my Availability Zone Impairment dashboard. For this demo, I'll update the pre-experiment duration to be 10 minutes and post-experiment duration to be 5. This will capture the steady state of the application before the experiment, as well as show how application recovered after the experiment. Experiment execution log will be sent to the CloudWatch log group I've selected. To make it easier to identify this experiment template later, I'll update the name to include Target Availability Zone and proceed to the next step. Now, I'll review the experiment configuration and proceed with the experiment template creation. Before we'll start the experiment, let's take a look how application is performing so far using CloudWatch dashboard. You can see a steady traffic flow. Amazon EC2 auto-scaling groups for both EKS and ECS have an equal distribution of compute across both US East 1A and US East 1B availability zones. There is steady number of connections to the database, with Amazon RDS Writer instance being in US East 1A and Amazon RDS Reader instance being in US East 1B availability zones. Time to start the experiment. We'll provide a name tag for the execution and confirm experiment start. You'll see the current state of the execution as well as resources identified as targets in the Report tab, Experiment Details in the Actions tab, and more information about experiment execution on the other tabs. Now, let's go back to the CloudWatch dashboard and check how the experiment execution will manifest itself on application metrics. Let's observe CloudWatch metrics. You can see that all zonal resources have been impacted. Let's check what happened with the Amazon RDS. There was a failover in the Amazon RDS from the impaired availability zone. Amazon EC2 autoscaling groups lost EC2 instances in the impaired availability zone and tried to recover capacity there, but were unsuccessful due to the availability zone being impaired. It will eventually provision required capacity in the healthy availability zone. Now we'll wait for the execution to complete, while observing the CloudWatch metrics. With the experiment completed, let's examine the CloudWatch metrics. You can see that during the experiment traffic still flew through the elastic load balancers, which moved the traffic away from impaired resources. There was, however, a short period when application wasn't available for the users, who later experienced temporary increase in latency across all the application components. Amazon EC2 autoscaling groups lost EC2 instances in the impaired availability zone, moved capacity to the healthy availability zone. After experiment has been completed, Amazon EC2 autoscaling groups automatically rebalance the capacity to same state as it was before the experiment. Amazon RDS moved the writer instance from impaired into the healthy availability zone. That impacted the connections to the database, causing short impact on the application. As you can see, AWS Fault Injection Service Scenarios library can make your chaos engineering efforts easier. By focusing on the availability zone, power interruption scenario, we showed the benefits of using pre-made experiments to test your AWS application's resilience. Thank you for watching this demo.